Okay, so let's talk about this. Let's talk about some of the effects of climate change specifically in forest ecosystems. And I've got a couple of examples that I want to go through and just do a little bit of work helping you distinguish the role of climate change in these events. And probably the thing that we want to spend the most time talking about relative to what are the biggest current measurable effects of climate change on forest ecology are tree mortality events. And we've had a major tree mortality event in California that's occurred in the last decade. About 300 million trees have been killed by bark beetle. And here's just an example of this. I took this photograph while I was climbing the East Buttress of El Cap in January of 2015. And there's two things to point out about that. Number one, it was winter and it was warm. I was hot that day. Second, many years in January, this is Yosemite Valley, and it would be full of snow, and there's no snow there. This was the height of the drought, very low snowpack that year. It was really dry. It was a great time to climb, but setting up potential devastation for the forest. And what you got right here down in this part of the photograph here is a little bit of tree mortality. And I remember seeing that and I was like, uh-oh, bark beetle. And you can even see going down the valley, you can see a little bit more scattered tree mortality here. Well, that's winter 2015, and not very long after that, excuse me, sorry, I went past it. Oh, geez, screwing this up. Not very long after that, tree mortality exploded, just went through the roof in the Sierra Nevada, and particularly in the southern Sierra Nevada, basically from Yosemite south. Yosemite Valley has been transformed from the landscape that it was just 5 years ago by tree mortality. The park had thousands and thousands of trees that were killed by bark beetle, and it's changed the feeling of the valley. I mean, it's gonna change it for the feeling of the valley for our lifetimes, all of us. I'm older than you, and even for you, it will not be the same. And that's, I would say that's, I'm not sure if it's good. I'm actually not sure if that's good or bad, but it happened. Now, I teach a whole class on forest diseases and forest insects. So I don't want to belabor that too much, but this photograph, I need to point out a couple of things to you. And this photograph is from the Southern Sierra. This is from the Needles area. I show this photograph a lot because it demonstrates the extent of mortality really well. And we also traditionally go there for this class and stand at the place where I took this photograph and kind of look at this. So this is 2016, and you can see there's a lot, the mortality is blown up. There's lots of dead trees. You can see them all here. Just again, pointing out that mortality here was triggered by drought and ultimately caused by bark beetle. So like I say, I teach a whole class on insects and diseases, and the things that you need to know about bark beetle in the Sierra Nevada are that, one, it's a native pest. It is part of these ecosystems. And these kinds of outbreaks have happened before, but they have been made worse by drought. And in particular, the drought that we saw in the last decade in California was a drought that we would expect to become more common with climate change, a climate change associated drought. So did climate change cause this bark beetle outbreak? Well, the bark beetles were here, but their outbreaks are certainly made worse by climate change type drought. Cool. And in terms of thinking more broadly about how climate change type drought will affect forest ecosystems, the impact will extend beyond California. And this is a photograph from Chiapas, and you can see this is this hillside is all pine. This is Chiapas, pretty high elevation. It's 2 to 3 or not quite 4,000 meters, but 6 to 10,000 feet. It's the southernmost state in Mexico, and it's got some high mountains, and those mountains are dominated by pine. And what you see here is this hillside, and you can see that the trees have been planted here. They're all in a row. There's all these trees that are in a row here. This has been revegetated, revegetated with pine. Pine silviculture, pine harvesting, pine forestry in Mesoamerica is an important part of the local economies. It's how people build homes and how they heat them. It's an important, there's an industry that's an important part of the economy. And in these places are also susceptible to bark beetles. They actually end up getting the bark beetles that are more common in the southeastern US, the southern pine beetle. It's a different species than what we get in California, but it does the same thing, kills lots of trees. And just to kind of give you a sense of how important these can be, in the 60s, the forest industry of Honduras was decimated virtually overnight by a massive outbreak of southern pine beetle. So, these kinds of things in places that are relatively poor and do not have a very diverse economy, a bark beetle outbreak can be very disruptive, economically, socially, and just for all of civil society. So, just the main point is these kinds of problems are not just in California. And I've got another example here, if this would advance. Let's see here. Sorry, it's gonna advance multiple times. This is a photograph this is going back to California. This is a photograph from Point Reyes National Seashore. This is tree mortality in bishop pine that's associated with drought and an invasive pathogen. So oftentimes we have an interaction between pests and pathogens that create mortality. But what I can say specifically about the interactions with climate change are, our current bark beetle outbreak, and I would say current because it's still somewhat ongoing, was made worse by climate change. And tree mortality events like this one in Point Reyes certainly have been exacerbated by climate change type drought. So, does climate change affect forests? In many different ways. We should expect it to. And furthermore, we have evidence that it is killing trees, and lots of trees, transforming forests in many different places. Here's another example. This is work from this guy Craig Allen and a bunch of other collaborators. He works for the USGS. And they've been able to show that tree mortality is a global phenomenon. It's been documented in recent decades on every forested continent. Most of the studies come from Europe and North America, the G7 countries, because that's where we have the research infrastructure. But there's reason to think that it's happening in the places that we're not necessarily studying also, because we have enough examples. You can see this map, the color coding is just the data sources. So all of them, the white dots, the red dots, and the black dots are all examples of studies that have documented tree mortality. Many of these are, more than anything else, these are associated in some way with drought and the kind of droughts that we expect with climate change. And they put together this kind of just nice schematic here, which is showing the number of drought events. So, you have few or many. This would say you have more frequent drought. And then the duration of drought, short droughts, long. And what this is showing here is that this is the distribution of drought frequency. So long droughts are rare, but they can be very damaging. Short droughts are common, and the question of how resilient are forests, how much loss of forest, how much mortality, how much change in forest should we expect, really comes down to what temperature these droughts are associated with. And that Millar and Stevenson paper that we read this week is really getting at that. What is the temperature associated with these events? And the problem is that droughts that most forests would readily cope with may quickly cross over a threshold into something that they cannot survive if the temperature goes up. And even a relatively small change in average temperature seems to portend extensive mortality of forests. And when, where, and why that matters is I think a next set of questions that are important. So, basically what this is showing is that if the temperatures are relatively cool, then the threshold for tree mortality is pretty high. Cool droughts, relatively cool droughts, like a lot of our forests are able to cope with that. But, you can decrease that threshold a lot, and meaning that a lot more drought events are going to cause mortality events if you increase temperature. And that seems to be what we're confronting. We should expect more of these kinds of events in the future. And so in this Millar and Stevenson paper, they've got some things here. NDVI is a measurement of greenness that you get from satellites. So it's the Landsat collects this information. And what this is showing is in the Southwest that we have a decrease in greenness. That could be because of increased drought, or it could be increased loss of forested land. We have, the other thing I wanted to point out is the area that's impacted by bark beetle. This is going up. And then there's also a trend in increases in wildfire area. And we're going to confront that more next week when we talk about fire and how it works and so forth. In general, and what I think is, what I think this is useful to put up, and kind of what I get out of it is just evidence that we are seeing a loss of forested area. We are seeing increased tree mortality in the Southwest, and I believe in their paper they're considering California as part of the Southwest. We're seeing a lot of impacts. Like I say, one of the points that one of the things that I want to do in any time that I discuss climate change is for us to make inference about it. Empirical. We need to confront the empirical data, because ultimately that's what we need to drive decisions. That is how you make a science-based decision. And I think that managing our natural resources are best done with a basis of science. So yeah, the Western U.S. is becoming drier. Mortality is increasing. They focus on bark beetle. That makes sense for the Southwest. It's the most important native pest or pathogen, and it seems to be the one that kills the most number of trees, just period. The paper that I submitted this week for revision was an analysis of sudden oak death, and we found that sudden oak death has killed about 50 million trees in the 2 decades it's been active in California. It's a coastal disease. 50 million is a lot, kind of a mind-bogglingly large number. But bark beetle, I'm certainly has killed more in the last 2 decades in California. So they're both important, but just to give you kind of a sense. Okay, and here's the last thing, science kind of thing that I want to bring up. And our first reading for this class was a book chapter that was published almost 30 years ago. So as I mentioned, you know, the science has advanced in that time. I still, like, I defend the decision to assign this book chapter because it's just very readable, and our understanding of, like, classifications of forests and the climate associations that, you know, give you a conifer-dominated rainforest, temperate rainforest versus something else, like that hasn't changed, right? But something that has is the expected forecast of how climate change will affect, how climate will change with, I think the term that's used in the book is global warming, an increase in global annual temperature. And I'm curious if any of you caught this, but one of the details in there is that there's a forecast for California to become wetter. So did that happen? It's been 30 years. Did that happen? Someone speak.
No.
No, it became drier. Good. No, it became drier. And, you know, many of our expectations have happened. Cyclonic storms have become more intense. That's your hurricanes, cyclones, and typhoons. Overall, you know, and I point this out because our models have improved. Our tools to forecast climate change have improved. A faulty model, an incomplete model, a forecast that is imprecise is not wrong. Our understanding of climate change and our understanding of its severity is not wrong simply because our models have gotten better. In fact, all models are wrong. What's said about modeling, and this is coming from a modeler, all models are wrong, but useful models tell you something. Useful models are the ones that you can learn something from. So it's dangerous if models will give you very specific answers, but you know, they should always be interpreted with the understanding that we don't know exactly what the future will hold. I was following coronavirus as soon as I got back from the Philippines in January because I'm into this stuff. I work on infectious disease, and I remembered SARS, and I remembered that that epidemiologists told us that we had really dodged the bullet with it. So I was following it, but I didn't expect it to become this bad. I didn't expect to be locked in my office and talking to you on Zoom. You know, we get, just because we cannot see the future doesn't mean that, one, we can't anticipate some things about it, and two, that it is developing better models is not worthwhile. It is worthwhile to develop better models. We need them. Improved science is not equivalent to controversy. So, and that gets us, that's a segue into the controversy, and let's acknowledge this, that things are really bad. There is a mountain of data that we can use to infer the severity of climate change and its consequences. But there is increasing discord among people, especially in the United States, about how serious of a problem it is and what we should do about it. And the situation is really crazy. You know, for example, you know, the platform of the GOP is generally not to do anything about, you know, this is one of the two major political parties in the United States, and the platform, I have trouble putting it into the right words, but it's basically, we're not going to do anything about that. And what is understood about elected members of Congress is that many of them acknowledge the science. that we have good evidence that the climate is changing and that it has consequences. However, our chief executive is one of the few people that will still dispute whether it is a problem, and that is very strange, and even making the situation more bizarre and probably harder to address from a policy perspective is that the politicians now seem to be right of even where what the industry says, is in particular the fossil fuel industry says about the severity of climate change, our confidence in that it is occurring, and what the implications are for our economy. It's really, really weird. And here's just an example of a poll, and it's not the results are not very surprising. Is climate change a serious problem? One party is by and large says that it is, and one party by and large says that it is not. What's interesting about these polls is, that's it. And then there's some people that seem to be undecided, and I still want to figure this out, but this doesn't add up to 100, so I'm not quite sure what's going on there. Okay. And I think one of the things, Greta Thunberg was in the United Nations last fall, and her, I thought it was interesting that she was there, and whether you agree with her or not about what do you do about climate change, or she's an example of somebody who's taken made some personal choices that seem to be very much at kind of on the extreme side. I mean, it's her life, right? So I respect that, even though I still fly. Well, I'm not these days, but I still fly. Her protest is very interesting in my mind, and this was kind of pointed out in this great article in the Atlantic from September. Why Greta makes adults uncomfortable, and I'll just read this here. If you come to see her schooling as part of an intergenerational exchange of welfare, students, you are in school now so that you can pay for the next generation to be, you can pay into Social Security and be supportive in their older age, then, she's got a very powerful economic argument to her specific protest, which is, I'm not going to go to school so I can pay for the older generation to retire, because you have betrayed me by ruining this planetary system that I need to live on. Whether or not that is fair, I just want to set it aside. Set that aside, whether you agree with her or not. It is an economically, in economics, it is a very valid idea. And the thing that I was so taken by about her comments to the United Nations is that you've stolen my dreams and my childhood with your empty words. And the part of this that has always resonated for me is your empty words. I cannot argue with that. There have been so many empty words and what have turned out to be empty efforts to address climate change. In that respect, she's absolutely right. Mostly policymakers have tried to pretend like this is going to magically go away somehow, rather than confront it straight on. I don't know, the reaction to her was I think kind of tragic, and it reflects a lot about the mountain that society has to climb. Bill McKibben was saying that Greta is attacked she's attacked personally because people can't attack the science. That seems right. And then there are these, immediately these comments about her being mentally ill or somehow being, just like go straight to Nazi propaganda. It's so predictable, and it's just very sad. And most tellingly, this is she was in the United Nations just last September. She's there making comments on climate change, and across town in New York, major fossil fuel companies were talking about pathways to reduce greenhouse gas emissions. I mean, it's crazy. It's like the interests, the economic interests, the energy companies can see the writing on the wall. And if you're an energy company, you are in the you're in the business of making energy, and you know that eventually oil is going to become more expensive and more finite. So of course you would be developing alternative forms of energy. This doesn't seem right. Something has gotten just something has gotten completely out of control here, such that even the interests that you would think would not necessarily be the interests that you would expect to downplay climate change, like fossil fuel companies, are now talking about how we can adapt to that. And it makes sense. I mean, if you don't have a good economy, then people aren't going to buy petroleum-based products. I mean, we're going through that now. Petroleum prices have cratered, gas prices are low, people aren't buying things. That's not good for the business model of Exxon and so forth, because if people don't buy stuff, then your company can't persist. Anyway, so this is just kind of, this is the last couple slides here have just kind of been, I want to make sure that I acknowledge the gorilla in the room here, the 5,000-pound gorilla in the room. And it's also part of just the whole context of what do we do about climate change. I mean, the political situation is completely upside down, and somehow we're going to have to get that right also to get people on board with policy changes. So if you're interested in this, and I know that a lot of you are because I've been talking to you about it, I think that's great. I think it's worth working on, even if we're going to see a lot of failures. And it seems like it's one of those problems where we don't really have a choice. You can either roll over and let this thing take control, or we can try to do something about it. And I really hope that you will try to do the latter. I've got a link to a YouTube video. I don't know if it'll work here. I'll stop the recording.